the cosmos, vast, enigmatic, and undeniably awe-inspiring. For millennia, humans have gazed at the stars, driven by an insatiable curiosity about the universe and our place within it. Today we stand at the cusp of unprecedented understanding, armed with revolutionary theories that challenge our very perception of reality. At the heart of this cosmic revolution lies quantum physics, a realm where the seemingly impossible becomes possible. Quantum physics delves into the hidden workings of the universe at its most fundamental level, the realm of atoms and the particles within them. It's a world where energy, motion, and other familiar concepts operate under completely different rules than those we experience in our everyday lives. This subatomic realm might seem distant and irrelevant, but its influence extends far beyond microscopic scales, shaping the stars, galaxies, and even the fabric of space-time itself. Our journey into the quantum realm promises to be nothing short of extraordinary, revealing the profound connection between the smallest constituents of matter and the grandest cosmic phenomena. Prepare to be amazed as we unravel the mysteries of the universe one quantum leap at a time. Imagine a world where objects can be in multiple places at once, where the very act of observing something can change its state, and where particles can be entangled across vast distances, instantaneously affecting each other. This is not the realm of science fiction, but the fascinating and perplexing world of quantum physics. In this world, reality is more like a collection of probabilities than a fixed set of events. Instead of being certain, outcomes are described by a wave of possibilities, each with its own likelihood of occurring. This is the strange and counterintuitive realm of quantum physics, a realm that defies common sense yet underpins the very fabric of our universe. It's a domain where the rules of classical physics no longer apply, and new, bizarre principles take over. Quantum physics, also known as quantum mechanics, emerged in the early 20th century as physicists grappled with perplexing observations that classical physics simply couldn't explain. These pioneering scientists, including the likes of Max Planck, Albert Einstein, and Niels Bohr, began to uncover a hidden layer of reality that was both astonishing and bewildering. The energy of light, for instance, seemed to come in discrete packets or quanta, rather than a continuous wave. This discovery led to the revolutionary idea that light could behave both as a wave and as a particle, a concept that would become a cornerstone of quantum theory. Atoms, once thought to be indivisible, revealed a complex internal structure governed by bizarre quantum rules. Electrons, for example, do not orbit the nucleus in neat, predictable paths but exist in clouds of probability, only taking on definite positions when observed. One of the most startling principles of quantum physics is wave-particle duality. This principle states that particles, such as electrons and photons, can exhibit both wave-like and particle-like behavior, depending on how they are observed. This concept states that particles, like electrons and photons, can exhibit both wave-like and particle-like behavior. In some experiments, they act like waves, spreading out and creating interference patterns. In others, they behave like particles, hitting specific points on a detector. Imagine a beam of light acting like a wave, spreading out and interfering with itself, yet simultaneously behaving like a stream of tiny particles, each carrying a specific amount of energy. This duality is not just a quirk of light but a fundamental aspect of all quantum particles. It's a mind-bending concept that challenges our classical intuition about the nature of matter and energy. The implications of wave-particle duality extend far beyond light, affecting our understanding of the very building blocks of the universe. As we delve deeper into the quantum realm, we'll encounter even more bizarre and counterintuitive phenomena. But don't be discouraged. The journey through quantum physics is not just a voyage into the unknown but a path to a deeper understanding of the universe itself. Each discovery, no matter how strange, brings us closer to unraveling the mysteries of reality. Step aside, atoms, we're diving into a realm far smaller and far stranger. In the quantum world, the spotlight shines on even tinier players, quantum particles. These particles are the true stars of the microscopic universe. These subatomic entities are the fundamental building blocks of everything we see and interact with, from the air we breathe to the stars in the sky. But they don't behave like the solid, well-defined objects we might imagine. Instead, they dance to the tune of quantum mechanics, a set of rules that defy our everyday experiences. Quantum particles such as electrons, quarks, and photons are often described as excitations of quantum fields. These fields permeate all of space, and the particles are like ripples on the surface of a pond. We'll explore these fascinating quantum fields in a later section, delving deeper into their mysterious nature. Quantum particles exist in a blurry realm of probabilities where nothing is certain until it is observed. This is a world where the act of measurement changes everything. Their properties, like position and momentum, are fundamentally uncertain until measured. This is encapsulated in Heisenberg's uncertainty principle, a cornerstone of quantum theory. Imagine trying to pinpoint the location of a buzzing fly in a dark room, an almost impossible task. You might hear it, but you can't quite put your finger on its exact whereabouts. This analogy helps us grasp the elusive nature of quantum particles. They are there, but their exact position is a matter of probabilities. One of the most intriguing aspects of quantum particles is their ability to exist in multiple states simultaneously, a phenomenon known as superposition. This is not just a theoretical concept but a reality that has been experimentally verified. It's like a coin spinning in the air. While it's spinning, it's neither heads nor tails. It's in a state of superposition, embodying both possibilities at once. This spinning coin analogy helps us visualize superposition. The coin only becomes heads or tails when it lands, just as a quantum particle's state becomes definite only when measured. Similarly, a quantum particle can exist in a combination of states, each with a certain probability of being observed. This probabilistic nature is at the heart of quantum mechanics. These particles don't just exist in one state or another, they exist in a blend of all possible states, each with its own likelihood. This probabilistic existence is what makes quantum mechanics so fascinating and at times, so perplexing. It's a world where certainty is replaced by probability. These quirky quantum characters and their bizarre behaviors might seem perplexing, but they are the key to understanding the universe at its most fundamental level. They hold the key to understanding the universe's most fundamental forces, from electromagnetism to gravity, and everything in between. And they are intricately woven into the very fabric of space-time itself, influencing and being influenced by the cosmos in ways we are only beginning to understand. Hold on to your hats, because the quantum realm gets even weirder. Quantum physics is a field that constantly challenges our understanding of reality. It pushes the boundaries of what we think we know, and forces us to reconsider the very nature of existence. One of the most mind-boggling aspects of quantum physics is its inherent uncertainty. This uncertainty isn't just a quirk or a limitation of our current technology, it's a fundamental aspect of the quantum world that has profound implications for how we understand the universe. This isn't just a matter of our limited measurement abilities, it's a fundamental property of the quantum world. At the heart of this uncertainty is the idea that particles at the quantum level don't have definite positions or velocities until we measure them. Instead, they exist in a state of probability, where multiple outcomes are possible. Heisenberg's uncertainty principle, one of the cornerstones of quantum mechanics, states that we can never know both the position and momentum of a particle with perfect accuracy. This principle is not just a statement about the limitations of our measurement tools, it's a statement about the nature of reality itself. The more precisely we measure one property, the more uncertain the other becomes. This trade-off is not due to any flaws in our instruments, but is a fundamental characteristic of the quantum world. It's a bit like trying to hold water in your hands. The tighter you squeeze, the more it slips through your fingers. It's like trying to simultaneously determine the exact location and speed of a moving car. The more accurately you measure its speed, the less certain you are about its exact position at that moment. This analogy helps us grasp the elusive nature of quantum particles, which behave in ways that defy our everyday experiences. This inherent uncertainty arises from the wave-like nature of quantum particles. Unlike classical particles, which have well-defined positions and velocities, quantum particles are described by wave functions that spread out over space and time. Just as a wave is spread out over a region of space, so too are the properties of a quantum particle. This wave-like behavior means that particles can interfere with each other, creating patterns of probability that are both beautiful and perplexing. Instead of having definite values, these properties are described by probability distributions, indicating the likelihood of finding a particle in a particular state upon measurement. These distributions are not just mathematical abstractions, they have real, observable consequences in experiments. The uncertainty principle might seem like a limitation, but it's actually a key to understanding many quantum phenomena, including the behavior of atoms, the stability of matter, and even the existence of stars. Without this principle, the universe as we know it would be a very different place. So, let's embrace the weirdness and explore its profound implications for the cosmos. The quantum world may be strange and counterintuitive, but it holds the secrets to some of the most fundamental questions about our universe. By diving into this realm of uncertainty, we open ourselves to a deeper understanding of the nature of reality itself.